Welcome back. Today we're diving into the science that can turn simple sand into computer chips or crude oil into life-saving drugs. Yep, we're talking about the science of change itself. So let's break down what chemistry really is and why it's one of the most powerful tools humanity has ever had. Okay, so let's get right to it. What is chemistry? I know it might sound a little intimidating, maybe it brings back memories of a high school class you'd rather forget, but the thing is, it's happening all around us and even inside of us right now. It's in the battery powering your phone, and it's how your body is digesting your last meal. It's really the how behind pretty much everything. The simplest way to think about it is this. Chemistry is the science of change. It's all about studying how one substance can become a completely different substance. It lays out the rules for how a green banana turns yellow or how gasoline explodes just right to move a car. It is all about transformation. And all of that change, every single transformation, happens to one thing: matter, which, is just the scientific word for stuff. All the stuff in the universe. And by understanding the deep down properties of matter, we can actually learn to control how it changes. And that control, that's the key to creating everything from brand new materials to new flavors in our food. But how do we go from just seeing these changes happen to actually understanding them? Well, it's not magic, and it's definitely not just random luck. Turns out, there's a really strict, time-tested playbook for asking questions and getting answers you can count on. And this is that playbook right here. It all kicks off with an observation. Something simple like, hey, my iron shovel gets all reddish and flaky when I leave it out in the rain. From there, you form a hypothesis, basically an educated guess. Okay, maybe something in the water is making the iron change. And then you run experiments to see if you're on the right track. You expose some iron to pure water, some to salt water, and keep some totally dry, all to nail down the exact cause. Now, this is where the language gets really important. A hypothesis is just that starting idea, that testable guess. But if you test it over and over and over again, and it works every single time under certain conditions, well, then it can become a law. A scientific law doesn't really explain why something happens, but it perfectly describes what will happen. Think of it like a rule you can bet on. So if a law tells us what happens, what tells us the why? Well, that's where a theory comes in. And listen, in science, a theory isn't just a hunch or a random idea. It is a massive, detailed explanation that's been built on a mountain of evidence from countless experiments. It's the story that ties all the facts together. And believe me, getting a theory established is a brutal process. I mean, scientists all over the world actively try to break it. They poke and prod it, looking for just one single exception. And only if it survives all of that without a single failure does it become the accepted explanation. That's what makes scientific knowledge so incredibly solid. So when you're studying chemistry, you're really learning more than just what's on the periodic table. You're learning this powerful, structured way of thinking. It's like a toolkit for solving problems that you can use for pretty much anything in life, way beyond the lab. All right, now that we get the process, let's talk about the results. Because this power to rearrange matter, it has completely reshaped our world in ways that are absolutely miraculous and sometimes in ways that are pretty dangerous. On the good side, the impact is just staggering. I mean, the chemical process for creating fertilizer is credited with feeding literally half the world's population. And almost every single pill in your medicine cabinet, from a simple pain reliever to complex cancer drugs, is a direct product of chemical innovation. It's incredible. But, of course, every big change has consequences. That same industrial genius that gives us amazing products also gives us pollutants that can harm our air and water. Natural chemical processes like corrosion cause billions of dollars in damage. And, tragically, the same science that creates life-saving medicines can also be twisted to produce incredibly destructive and addictive drugs. And when you break it down, you see these are all major challenges. Now, this isn't about blaming chemistry itself, but it's about recognizing the huge responsibility that comes with this power. Understanding these negative effects is always the first step to figuring out how to fix them. And this brings us to a really beautiful point. The exact same science that helps us understand why iron rusts is the very same science that gives us the tools to stop it. Things like advanced coatings or special metal alloys. So often, chemistry is the key to solving the very problems it helps us discover. So, if chemistry is this amazing tool for finding and fixing problems, who are the people actually using it every day? Let's take a look at how this fundamental science turns into real-world careers that shape all of our lives. The short answer is they're everywhere. You'll find them in the health service, creating new drugs, in food processing, making our food safer and last longer, in forestry, checking on the health of our environment, and of course, in agriculture, developing better ways to grow our food. And while all those fields are absolutely vital, there's one area in particular where chemistry's impact on our health is just impossible to ignore. It's a field built almost entirely on our ability to control and create molecules. And that field, of course, is modern medicine. From understanding how diseases work on a tiny molecular level, all the way to designing the specific drugs that fight them, medicine is truly one of the greatest stories of applied chemistry ever told. And that brings us right back to where we started. We defined chemistry as the science of change. We've seen its power to transform our world, for better and for worse. So the real question isn't just what chemistry can do, but what are we going to ask it to do next? What huge change, like solving our energy crisis or finally curing a disease, is just waiting for the next big chemical discovery?